Oh, why am I writing that? Oh my god. I found a page and wrote it. Just kidding, guys. Inscribed angles. You didn't even see. Good. Inscribed angles and polygons. All right, how do I use inscribed angles and polygons to solve for angle measures? How many of you did your homework? All right, good. So where's the central angle located? In the center. And the arc that is with the central angle, are they the same or are they different? The arc's on the outside, right? The angle's on the inside. But is the measures the same or are they different?
Oh, it's the same.
Is this angle is what? 90. The angle's 90 and the arc is 90. So the angle and the arc are the same. So even if I wrote 90 out here, it would still be the same with the angle, right? Make sense? Okay, today's not like that. Which is why if you did your homework, then you have yesterday down, and now I'm adding something different. Okay? Inscribed angle. Inscribed angle is an angle whose vertex, what does it mean to be the vertex again? Where the two, they're called rays, where the two rays meet is where your vertex is, so your angles are here, right? So this is your vertex. An angle whose vertex is on, keyword, on the circle. Yesterday it wasn't on the circle, it was where? Where was the vertex located yesterday? In the center. Today it's not in the center, it's on the circle. Okay? And whose sides contain chords of the circle. What does it mean to be a chord? What does it mean to be a chord? Notes will take us a really long time. What does it mean to be a chord? A segment whose endpoints are on the circle. Is a diameter a chord? Yes. Is a radius a chord? No. No. A radius is not a chord. A diameter can be a chord, but a radius cannot be a chord because both endpoints have to be where? On the circle. So, is that an angle? Yes. Are those two chords? Yes. Notice the angle is not where? It's not on the center. It's on the circle. Oops. It's on the circle. Okay? Now, we have another word. Intercepted arc. Intercepted arc is the arc that lies on the interior, what's interior mean? Good. Of an inscribed angle and has endpoints on the angle. So intercepted arc is the arc that lies in the interior of the inscribed angle and has endpoints on the angle. So your intercepted arc is very easy to find. Do you see where your angle is opening to? Yes? There's your inscribed arc, or intercepted arc. It's right here. Okay, so your intercepted arc is on the inside of the angle. So notice the angle is opening to the inside. We don't look at this part as the angle. It's this part over here. That's the angle. Okay? So get me through 6th period right here. All right, let's talk about the measure. Oops. Measure of an inscribed angle theorem. It wasn't too bad. Here, we'll do this. I'm going to leave this here for a second. So the people watching the recording can take a picture of this part because it's froze. So measure of an inscribed angle theorem. Measure of an inscribed angle theorem. Okay. So before I actually do this, you see your angle, yeah? All right. So see my rubber band? Let me zoom out. All right, see my rubber band? So here's my rubber band, yeah? I'm going to make an angle. Let me see if I can do this right now. There we go. So here's my angle, yes? We'll pretend this part over here where my 2 fingers are is the arc. So let's pretend it's curved, yes? Okay, so when I'm looking at my angle, is the angle over here small or bigger or equal to the arc? Smaller. Do you see it? The angle is smaller. So even if I make a bigger circle, the angle is still what? Smaller than the arc. Now if it's in the center, then it's about equal, right? But if it's not in the center, we're pulled out. So the angle is always what of the arc? Smaller. Does that make sense? Do you see it? Because that is going to be the theorem I'm going to write. So the angle is smaller than the arc. Got it? So what's bigger, the arc or the angle? The arc. Okay? So what the theorem says, oops, it says the measure of an inscribed angle is half the measure of its intercepted arc. So the measure of an inscribed angle is half the measure of an intercepted arc. So make a note, what's bigger, the angle or the arc? The arc. Because anytime you see 1/2, you guys forget which way the 1/2 goes. So here's circle C. Here's angle ADB. Do you see the angle? We have angle ADB. So we're going to say that the measure of angle ADB equals half the measure of what's the name of the arc? AB. Okay? So the angle is equal to half the arc. You should know which one's bigger. Notice, yesterday they were equal. The angles in the arc were the same because you were located where? In the center. Do you see how I'm trying to drill that part into your brains? Because today you're not in the center at all. Okay? Good? We're going to do more words. Then an example. meters. So it says, if two inscribed angles of a circle intersect the same arc, then the angles are congruent. If two inscribed angles of a circle intersect the same arc, then the two angles are congruent. Draw a circle. Your circle should have a picture that looks like this. Yeah? Alright, from here we're going to have a couple points. A to D, to B, to C. Okay? All right, ready? Let's highlight. Or you can watch me highlight for a second. I'm going to highlight one of the angles, okay? I'm just going to pick an angle. I'm going to highlight angle A, D, B. Okay? Do you see angle ADB? Okay. As you're looking at angle ADB, what arc does it have? What is its intercepted arc? Arc what? Arc AB. You see it? Okay. Now, is there another angle that opens up to the same arc? What is it? Angle ACB. Also opens up to the same arc. So even though they're located in two different areas, even though they're located, they're opening to the same arc, which makes them congruent. Okay? So I'm going to write the piece that goes with it. It says that angle ADB is congruent to angle ACB. If the angles are congruent, then their measures are also the same. Right? So if the angles are congruent, then their measures are also equal. Make sense? Questions? Beautiful. Example 1. In this example, you're going to find the measure of arc RS and the measure of angle STR. Now, ladies and gentlemen, you don't have to be great at this right now, but you need to try. Because you need to decide to be an active learner or if you're going to be a passive learner. What does it mean to be passive? Not just quiet. You're just going to do what? What's active learner? Trying. Does it matter if you get it wrong? No. It's not a test. It doesn't matter right now. But you need to try. Otherwise, when you get home, you won't try. All right, so here's my new circle. I have S, T, U, and R. The 31 degrees is pointing right there into that little spot. You see it? All right. I suggest you highlight. Okay? You have one angle, use it. I suggest you highlight. I'm going to let you try it. Talk with someone next to you. You've had a minute to look it over. Talk with someone next to you. I don't care if you're stuck. You need to talk to the person next to you. Even if you just highlighted, talk to the person next to you. Jamie, talk. Well, maybe she knows. Did you highlight? That could be a problem. Ready? What angle do I have? And you can't call it U. Why can you not call it U? You have angle S, U, R. Psst. My turn now. We do have angle S, U, R. S, U, R. Opens up to what arc? S, oh, look at that. Isn't that the same one I want? Oh, okay. What do you want to do? You want to find it? What do you want to do? Tell me what to do. You can find the measure of STR? Okay. So, what do you know about this arc and this angle? Is there another angle? What is it? STR. So it opens to the same arc, yes? If it opens to the same arc, what do you know about your angles? Okay. So what's my first angle I started with? The measure of angle SUR equals how much? Equals 31 degrees? Okay. And then you want to say what? Tell me what to say. I don't know. The measure of angle STR equals the measure of angle SUR. We should probably say that first. So then I know that the measure of this is equal to 31 degrees. Who had that? Oh, wonderful. Was it actually easy if you highlighted it? Was it easier? Yeah, otherwise you just see these lines and you don't know what you're looking at. Well, I knew I had 31 degrees, so if I highlight that angle, then I know that it opens to this, and that's what I was looking for, so then there's not a whole lot of work here, right? Use the tools I give you. I don't highlight for me. I did geometry in 9th grade. I don't highlight for me, guys. I highlight for you, right? And my geometry teacher taught to the board. Like, literally, it was boring. All I could think about was it was 4th period and what I was eating for lunch. So, true story. What's the next part? Who's on the angle? Check. What's next? Measure of the arc. What's the arc I'm looking for? Okay, so what angle opens up to the arc? Start with the angle you're given. Angle SUR. Do I know anything about that angle? It's equal to what? It is 31, but it's equal to what? What does the theorem say? I already did that part. Half of the measure SRRS. Does it matter which way I label it? Not really. Okay, what's this angle? You told me already. How much is it? 31 equals 1/2. Do you know what this is? Do you know what the measure of arc SR is? When you don't know it, what do you call it? Okay. How do you solve this? Multiply by 2. When I multiply by 2 on this side, what happens to the 2 and the 1/2? They cancel. And I get x is equal to 62. But I don't want 62. I want to know the measure of the arc. So I need to say the measure of arc RS or SR, whatever it is, equals how much? 62 what? Degrees. So in reality, was this problem very difficult? No. Does it make more sense when you highlight? Yeah. There's a reason for my madness. Got it? Okay. Next. Another word. Inscribed polygon. All the vertices. What's a vertice? Or why is it vertices and not many what? Vertex. Like vertex. That sounds weird, but we have more than one vertex. All the vertices of a polygon. Is a circle a polygon? Why? Does it have a vertex? Nope. Lie on the circle. All the vertices of a polygon lie on a circle. What's a polygon? A rectangle, a square, so a quadrilateral, a triangle, a pentagon, a hexagon, any shape, right? That has a vertice, so it has to have a vertex. So all the vertices of a polygon lie on the circle. You did this last year in IM1. You constructed a square, a rectangle, and a hexagon inside a circle. You did. I did. I pray you did. Okay? He did. Yep. Here's your inscribed polygon. So your polygon is here. Is your inscribed polygon. This next part is called circumscribed circle. It says a circle that contains the vertices. Circle, inscribed polygon. Got it? You did this last year. You did. You may have been absent here, but you were physically there. What teacher? She taught it. Pretty sure. Pretty sure she did. Pretty sure. Pretty sure it looks like this. I know you did it.
It looks like.
Oh, yuck.
And like this.
Did anyone have Anderson?
No, I didn't. You didn't go here. We're going to pop them tomorrow at Freshman Luau. You're not invited. You can watch as much as you want, but you can't do it. You can come watch us and wave. Next year.
And then run up and pop all of them.
No. That's not how it's working. I think not. I think no. Alright, ready? We have a theorem. Theorem 10.9. I know, guys. I'm trying to at least break it up with like examples in between. I said that.
Oh.
You should listen.
That looks like a G.
Well, what it looks like and what it is are two different things. You should listen.
I am listening, but like,
If a right triangle
my eyes tell a different story.
is inscribed in a circle, the hypotenuse is a diameter of the circle. Conversely, if one side of the triangle is a diameter then the triangle is a right triangle. Circle. Center. So what does it say in English? It says, if you have a right triangle inscribed in a circle, then the hypotenuse is the diameter of the circle. So the hypotenuse, no matter what, is going through the center. We're going to pretend that's the center. And then we're going to form a right triangle. Yeah? So if you have a triangle, it doesn't matter where the triangle, if it goes through the diameter, then you have a right triangle. Got it? It also says, conversely, if you don't know it's a right triangle, but you have a triangle in there, it's a right triangle, as long as it goes through the diameter. Got it? And the right angle is always going to be located right across from the diameter. So it's not going to be the ones touching, which call this A, call this B, call this C. Okay? So I know the measure of angle ABC, oh, just kidding, ACB, I did that backwards, equals 90 degrees if and only if segment AB is the diameter. Okay? Let's add something to it. A quadrilateral. How many sides to a quadrilateral? 4. Can be inscribed in a circle if and only if opposite angles are supplementary. What does it mean to be supplementary? They equal 180? That's wrong words to say. Let's use the right words. 180 is correct, but we need to use the correct words to get up to that. Add up to 180. That's different. If we say equal to 180, that means only one has to equal 180. But if they add up to 180, then we're adding two things. Yes? So quadrilateral can be inscribed in a circle if opposite angles are supplementary. Ladies and gentlemen, when you did quadrilaterals, were opposite angles supplementary before? When you have a basic quadrilateral, this angle and this angle are supplementary? No, they're not. They're what? They're congruent. Now I'm throwing it in a circle and they're no longer congruent. Do you understand? You need to know the difference because guess where that's going to show up? The final. Oh, let's talk about the final really quick. IM2 final. Yeah, it's in June. It's about 40% first semester. Yep, about 60% second semester. As of right now, it could get close to 50-50. Got it? We have to, because second semester validates first semester. So remember I said the main things from first semester you need to know or you won't pass IM2? Starts with an F. Factoring. Starts with a Q. Quadratics. First semester. And when you start IM3, that's all first semester. They add to it though. Alright, quadrilateral DEFG located in circle C. Yes? My goodness. My email's not even set up. Alright, DEFG lie on circle C. If and only if the measure of angle D plus the measure of angle F equals 180 degrees, and the measure of angle E plus the measure of angle G equals 180 degrees. Alright, example 2. That's what we should probably draw. Circle. Alright, there's your circle. I want to know what's the measure of angle BAC. Got it? Okay, get it done. Did you solve? Do we have an answer? Who has an answer? What do we get? How'd you do it? What did you write? The measure of angle BAC equals 1/2. The measure of arc BC. Say things correctly, yes? Okay. Angles on the inside. I cannot ever hold this thing correctly. Okay, so the arc's on the outside, yes? All right, what's the measure of the angle? Do I know it? Call it what? Good. Equals 1/2 of what? 84. 1/2 times 84 is 42. So the measure of angle BAC, 42 degrees. Very good. Who's right? Wonderful. Much better than third period. One more example. There we go. Elizabeth, pick up your head. Can't be that tired. You have no idea, guys. God bless you. I'm going to say find A and B, little a and little b. Draw a circle. This is the last thing I'm doing. We're going to call this M. I'm going to call this J, K, and C. Call this 3A degrees. Call this 4B degrees. 130 degrees. 54 degrees. 110 degrees. Okay. How many of you actually tried it? Good, you're being active learners. How many of you highlighted? Good, that should have been the first step. What did you highlight? Give me one thing you highlighted. Probably an angle. What angle did you highlight? MCK? Wonderful. That's a good one. Why'd you highlight that one? Why would you highlight that one? Because it has what? I could have highlighted MJK, but why did I not highlight MJK? What's your angle labeled at? What's it labeled at? The longer you sit here, the longer it takes. I'm getting through this whole problem. What is it labeled at? I heard it back there. 3A. Don't I want to solve for A? So don't I care about that angle? Yeah. I don't want to highlight MJK and there's nothing there, correct? You got to highlight the things you need. Okay. If I highlight that angle, what's the intercepted arc? MJK is the intercepted arc. Very good. Okay. Now, learned yesterday there's this thing called arc addition postulate, yeah? Oh yeah. And we also learned that a whole circle is how many degrees? How many of you actually use 360 on this problem right now? Good job. You have to. Why? Because you're missing a piece. You know from here to here is how much? And then from here to here is, and then from here to here, and then from here to here, oh, I don't know. So how do I find it? Add, and subtract from? Wonderful. Do it. Good. You have to use your brains. It's a lot of common sense, guys. It's not very explicit. The geometry sections are very like, what do you know? What can you find? Can you use that to solve? It's not a very explicit, like, here's a quadratic, graph it. It's not like that. Okay? It's what do you know about a circle? I know it's 360. So what am I missing? How much does it add up to be? 294. So when I subtract, I get 66. So now this is 66 degrees. Wonderful. Good? Do I have the whole arc now? So can I set up my problem? Do you see how we have to use this thought process? You have to start with, what do I know? Well, I know a circle's 360. I have everything except for this piece. Okay? Okay, so let's set up this angle. I'm going to say the measure of angle what? MCK equals 1/2 the measure of arc MJK. Do you know what the measure of angle MCK is? What is it? 3A. 1/2. What's the measure of the arc? I don't know. What am I adding? Oh, good. So write that out. I don't do it in my head. Write it out. So what is 54 and 66? How much? 120? What does it mean to multiply by 1/2? Divide by 2. So what's 120 divided by 2? 60. And what's A equal? 20. Good. Okay. I found A. Go find B. Highlight with different colors. Otherwise, you might get confused. You should be done, yeah? Do something. What'd you get? I'm going to highlight the angle. Our angle is JMC, yes? So if that's the angle, your arc is JKC. Where does the angle open up to? Got it? Okay. Who has an answer? Good. I'm going to start off with the measure of angle. What's the angle again? JMC equals 1/2. What's the measure of the arc? What's the arc we're looking at? JKC. Okay, what's the measure of angle JMC? 4B equals 1/2 times 66 plus 110. I kind of squeezed that in there. So 4B equals 1/2 times, what's that add? 76? Sorry, I heard two different answers. So I get 4B equals how much? 88, and B equals, who's right? Make sense? My hint to you is you have to draw the pictures. You have to write on the pictures. You have to highlight the pictures. Do you understand? Notice when I did this first one right now, as soon as I highlighted it, I noticed I was missing a piece. So guess what I had to do first? Find the missing piece. Why are they in there? You have to do all of that stuff first before you actually solve that what it's looking for. Do you understand? Okay, homework. In the purple book again. Yeah, the geometry book. 676. Numbers 3 through 8, 10 through 15, and number 18. You're going to fold your paper into 8 boxes. You can do 8s. If you write really big and you draw your pictures really big, then you're going to need a bigger box. But for the most part, it's each their own problem. Okay? If you're not drawing the pictures, your homework's going to be what? Incomplete, and I'm not grading it. Or it will get a 2 out of 4, depending on how much you did. It might get a 1 out of 4. Got it? Make sense? Okay. Summaries, questions, all of that fun stuff. If you want to take a picture of the book, you can do that too. You still have 6